Well, hello guys, and welcome back to Mr. G Physics, the channel that can help you to improve your marks in physical sciences from grade 8 to grade 12. This time we're going to be doing a question on free body diagram for the grade 11, however it's very much applicable for the grade 12. If you didn't subscribe, please do it now so you can get all the notifications and videos I post on regular basis. This question says block 1 is connected to block 2 by a light inextensible rope. The same type of rope is attached to block 2, run over a light frictionless pulley and connected to a motor. And the motor pull the system up a rough incline. Since the moment they say rough, it means there is frictional force. When they say the word rough, as you can see it here, it means the system or the surface have friction. That is an important thing here. And the plane is inclined at an angle theta, an angle alpha to the horizontal. The motor applies a constant force which causes the system to accelerate. The force applied by the motor is parallel to the plane. And guys, this is the picture we have. We need to draw the free body diagram representing all the forces on the blocks, on each of them. Now, the free body diagram included all the forces, no axis, no component, no block. All right, but however, we are going first to look at the forces acting on this picture. And let's begin by M1. What forces are acting on M1? First of all, we have the weight of the object pointing straight down. This one here will be the weight 1 or weight for that object. Okay, what are the forces? Well, the surface is acting on that object perpendicular to it, which is the normal force. We're going to draw it right here. This one is the normal force acting on that block. What are the forces? There is friction pointing in the opposite direction of motion. That is a friction. It's going to be a little bit too close. Maybe if I change color, this one here is frictional force. That tension from the second block. Note that force is from the second block, is the tension on the rope. It is not the tension of the motor. Okay, so this force that this rope is exerting, or block 1 is exerting on block 2, which is called tension. All we're going to do now is to draw the free body diagram for M1. So we're going to write here for M1. Remember, the object is going to become a dot, and all the forces will be coming out of the dot, not towards the dot. And let's represent the forces. All we have to do is take the same forces there and represent them here. Weight was straight down. This one was weight. Normal was perpendicular to the surface, so it is in this direction. This is normal force. Friction is parallel to the surface, therefore must be perpendicular to normal. And be careful with that one. This one is frictional force. Okay, note, because the normal is perpendicular to the surface and frictional force is parallel to the surface, make sure this here is 90 degrees. You obviously don't have to write that one there. So be careful. And then finally we have tension, which is also parallel to the surface. So this one here will represent the tension. In actual fact, we have to draw it a little bit longer, but it does not really matter. This is the tension. Now, why did I draw it bigger? Because the net force in this system is actually upward, and then that tension should be greater than the addition of the component of the weight and the friction. But this one is for another time. So guys, this is the free body diagram for this question. If you do this one in test, you will get 1 mark per each force. Note, each force must have the heading or the name of the force as well as the arrow, the head of the arrow. Otherwise, you don't get mark. Now let's go to block 2. So what forces we have on block 2? Well, weight is pointing, no, that is not going down. Weight is going straight down for object 2. There is the same. We have normal in the same way. Let's start from the surface. This one is normal force. We have the applied force. This one here is the applied force from the motor. which is parallel to the surface. They say it in the question. This one is the applied force. It's force coming from the motor, the pulling force from the motor. And then we have frictional force. Remember, is parallel to the surface. Frictional force parallel to the surface, but it's also tension. So this M2 or block 2 is also pulling backward this block 1. So there's also tension. So in this case, we actually have 5 forces, and be careful with that. Let's do it clear now in a free body diagram. And let's see if I move this one a little bit. Maybe I have enough space there. Yes. Let's see, this one is for M2. I want to do it here so you can see it clear. So for M2, we're going to do it there. I think will be enough space if we compress it a little bit. So we have the object. That dot represents the object. And what forces are acting on this object this time? Well, we have weight, which is straight down. Remember, it's towards the center of the earth. This one is weight. Okay, what else? There is normal force, which is perpendicular to the surface. This one is normal force. There is friction. Remember, friction and normal should be at 90 degrees because friction is parallel to the surface. So this one is frictional force. So when you draw in the friction and the normal, if there is friction, of course, you have to make sure this angle here between the two of them is 90 degrees. So you can do it actually with the stream of a ruler if you think you are going to get confused, so you don't have the correct instrument. However, there is the applied force of the motor forward. This is the force with which that motor is pulling the system of blocks. I'm going to call it applied force. But guys, there is also the tension from the rope backward. So we need to have here also tension. I'm going to draw it there with the blue one. This one is also tension. In this case, you have 5 forces. Once more, if you do this one in the test, you will get 1 mark per force. Okay, so it will be 5 forces. Note the following: if you make a mistake and you have an extra force, guys, you will lose 1 mark. So guys, this is all for now. This is our free body diagram. We still have to go to Newton's first law and explain that one. I'm planning to do some experiment about that, but I'll see you next time. If you didn't subscribe for the channel now. I'll see you next time in this video.